Good morning, students. So we were discussing about the design of footing, and the main two criteria for design of footing is bearing capacity criteria and settlement criteria. Okay, so by Tersagi's equation, we have studied how to calculate the bearing capacity of a soil, and by knowing the bearing capacity of the soil, we can choose what type of foundation is to be provided for that particular type of structure. Okay, so first criteria is bearing capacity criteria that we have studied. Second criteria is settlement criteria, that is the settlement of the soil should be within permissible limit. Okay, so by satisfying these two criteria, we can continue with that footing, that type of footing, that is the soil should have bearing capacity, or the soil should have minimum shear strength to withstand the external load, and also the settlement should be within permissible limit. So these are the two main important criteria while we are designing a footing. Okay, so second one is settlement of a foundation. So in today's lecture we can discuss different types of settlement. Okay, that is due to the external load on the foundation, there are mainly three types of settlement. First one, elastic settlement, then consolidation settlement, and secondary consolidation settlement. And elastic settlement means, elastic settlement is also known as immediate settlement, and this immediate settlement takes place immediately after the application of the external load. Okay, that is immediately after the application of external load, there will be a rearrangement of the soil particle, or there will be change in shape of the soil structure. And this type of settlement immediately after the construction of the structure is known as immediate settlement, and is also known as distortion settlement, since it is due to the distortion within foundation soil. Okay, so the first type of that is immediately after the application of load, the settlement takes place is known as elastic settlement, and it is due to the distortion of the soil particle, and that is known as elastic settlement or immediate settlement. And after that, that is after the rearrangement of the soil particle, the next step is expulsion of water from the voids. So that is the second stage of settlement, and it is known as consolidation settlement. And the consolidation settlement occurs due to the gradual expulsion of water from the voids at the soil, and it is determined using Tersagi's theory of consolidation. So that is the second stage of settlement, consolidation settlement, and it is due to the expulsion of water from the voids. Okay, and after expelling all the water from the voids, then occurs secondary consolidation settlement, that is the settlement occurs after completion of primary consolidation, that is after the complete expulsion of water from the voids, secondary consolidation settlement occurs. And this type of settlement, that is the secondary consolidation, is not much important for for some types of soil. It is not much important, and in the case of inorganic soil, it is non-significant. Okay, so this is not much important, and these two are very important, that is immediate settlement and consolidation settlement. Okay, so these are the different types of settlement due to the external load, that is immediate settlement, then consolidation settlement, and secondary consolidation settlement. So the total settlement is the sum of immediate settlement plus primary consolidation settlement plus secondary consolidation settlement. Okay, then causes of settlement. So what is the cause of this settlement? And it may be the pressure of the structure to the ground, due to the pressure of the external structure, and the structure may be a building or some backfill soil or dam, etc. Okay, so due to that settlement may occur. Then another cause is change in soil water content, that is due to primary consolidation settlement, that is if there is any change in soil water content, it will cause primary consolidation settlement, and so this is another cause of settlement. Then next cause is the vibration caused by impact, piling, blasting, and heavy machinery, that is there will be piling operation, blasting, and heavy machinery operation which is taking place near our structure. Okay, so this vibration of this nearby area will cause settlement for our particular area. So that is another cause, vibration, which is caused by impact, piling, blasting, and heavy machinery. Another cause is expansion and contraction of the soil. Due to the expansion and contraction of the soil, the settlement of structure may take place. Then movement or soil erosion is also another reason for settlement, and other causes like soil digging in the nearby area. So these are the some causes of soil settlement. Next, there are different types of settlement. First type is differential settlement. That is, differential settlement means the relative settlement between one part of the building to the other part of the building. That is, in the case of differential settlement, the settlement of the building parts are different. That is, one part of the building settles more than that of the other part. Okay, so it will cause irregular settlement of the structure. There may be tilting of the structure. That is known as differential settlement. For example, leaning tower of Pisa. Let's say I have included here. This is the example for differential settlement. That is leaning. This is leaning tower of Pisa, and now it is cleared. This problem is cleared. Here, this part of the building settles somewhat more than that of this part. That is, settlement is not uniform. Okay, so this is the figure. Here this column will settles more than this column, so there is a tilting of this building. So this is leaning tower of Pisa, and tilting occurs due to differential settlement. Okay, so differential settlement means this relative settlement between one part of the building to the other part of the building, and may cause stress that can result building to crack or collapse. So that is the final result of differential settlement, that is the building may crack or collapse. Then differential settlement, the difference between the magnitudes of the settlement at any two points is known as differential settlement. Okay, so since there is difference in the magnitude of settlement, that difference is known as differential settlement. And if there is large differential settlement between various parts of a structure, distortion may occur due to additional moments developed. So if there is large differential settlement, moments will develop and it will cause distortion or crack or collapse of the structure. And the differential settlement may cause due to tilting of a rigid base, dishing of flexible base, or due to non-uniformity of loading. So these are some causes, that is tilting of rigid base or non-uniformity of loading, etc. These are the causes of differential settlement. And if S1 and S2 are the settlements at 2 points, that is for first point of the building the settlement is S1 and the last point is S2, then the differential settlement is equal to delta is equal to S1 minus S2. That is the differential settlement, that is difference between the settlement of 2 points. S1 minus S2 is the differential settlement. Then it is expressed in terms of angular distortion. Angular distortion means differential settlement per length, that is S1 minus S2 by L, which is equal to delta by L. That is differential settlement per length of the building is known as angular distortion. That is delta by L is known as angular distortion. This is one parameter by which we are expressing differential settlement. And it is difficult to predict the differential settlement, and is generally observed indirectly from maximum settlement. That is, we cannot predict the differential settlement, so we can assume this differential settlement from the value of maximum settlement. That is, it is observed that the differential settlement is less than 50% of the maximum settlement in most of the cases. Okay, that is if the maximum settlement, that is if we know the maximum settlement, differential settlement will be less than less than half of the maximum settlement. Like that we are assuming the differential settlement. That is, in field it is very difficult to measure the differential settlement. So by knowing the maximum settlement value, we are taking differential settlement as less than half of the maximum settlement. Okay. And the differential settlement can be reduced by providing rigid raft, that is by providing raft foundation, and founding the structure at greater depth. That is another solution of differential. That is, if we are constructing the structure at a greater depth, there will not be any variation in soil strength. Okay, that is, if we are digging a greater depth, we may reach some rock like some rigid structure. Okay. That is, at topmost layer the soil will be flexible and it may be soft, and there will be different layers of soil. Okay, so there is more chance of differential settlement at top layers. And if we are digging a larger depth towards in downward direction, we may reach some stable structure, so it will avoid differential settlement. So another solution is founding the structure at greater depth and avoiding eccentric loading. So these are some measures to reduce the differential settlement. Next is allowable settlement. So up to this we have discussed what is differential settlement. Next is allowable settlement. Allowable settlement means the maximum settlement which is allowed to the structure. Okay, the allowable maximum settlement depends upon the type of the soil, type of foundation and structural framing system. Based on, we have provide some value as allowable settlement. The maximum settlement ranging from 20 mm to 300 mm is generally permitted for various structures. So this is the some settlement is allowed for some type of structures. Okay, so if it is greater than this allowable settlement, it will fail. So that is in code, that is in IS 1904 and 1978 gives the values of the maximum and differential settlement of different types of building. So if there is some value for allowable settlement, that is some settlement is allowed for some kinds of soil, and for different types of soil the allowable settlement is varying, and it is provided in the code. So that is known as allowable settlement, and the maximum settlement ranging from 20 mm to 300 mm is generally permitted for different structures. And theoretically, no damage is done to the superstructure if soil settles uniformly. That is, if the settlement of the soil is uniform, it may not cause any damage to the structure. Okay, because in some cases, if the building, for example, if a building settles uniformly, that means some case the first floor of the building may become the ground floor, but we can reuse the structure. Okay, there will not be any tilting since the settlement is uniform. So this uniform settlement will not cause much damage to the structure. We can use the structure by converting first floor to ground floor, etc. But if it continues, it will damage the water pipe, electric line, etc. That is a problem. However, settlement exceeding 150 mm may cause trouble in utilities, like, that is, if the uniform settlement, since even though the uniform settlement is not dangerous, but if it exceeds 150 mm, it will cause troubles for water pipelines, sewers, telephone lines, and also access from streets. So that is a problem if the uniform settlement exceeds that limit. Okay. Next, differential settlement. So this differential settlement is very important. So we have to discuss the measures to reduce the differential settlement. Okay. So as we told, settlement of the foundation soil is vertical displacement of the soil surface caused by workload of the building. And during and after building construction, settlement of the foundation structure is considered normal and acceptable to a certain extent. That is, we have given allowable settlement value. So within that allowable settlement, it is allowed. That settlement is allowed for particular limit based on the type of soil and the load. Okay, but if it exceeds the permissible limit, it will cause damage. However, potential problem occurs with the differential settlement, but the differential settlement is very dangerous. Differential settlements are uneven foundation settlements that can be result of numerous causes. So there are so many causes for differential settlement. So this is uniform settlement, that is, the building is settling downwards uniformly. So in that case, it will not cause so much damage, but if it exceeds the permissible limit, it will cause failure of the water pipeline, electric line, telephone line, etc. And this is tipping structure without crack, and this is differential settlement, and it will cause crack or damage to the entire building. So this is an example of differential settlement, that is Leaning Tower of Pisa. Settlement of different parts of the building is different, so that difference is known as differential settlement, and is expressed in terms of angular distortion. That is differential settlement, that is S1 minus S2 divided by length of the building. And the causes of differential settlement, we have discussed some points before. The causes are difference in soil layers in a single site. That is, in a single site there will be different soil strata. The soil properties are varying. Sometimes in some layer the soil may be soft, sometimes it may be hard. Like that, in different layers, or by varying the depth, soil properties are also varying. So it will cause differential settlement. Okay, that is here also. Here in these two sections the soil property may vary. That is, here the soil may be very low, so here there is more settlement, and in here this soil may be somewhat more stronger than this soil, so here settlement is less. So like that, if the soil property varies within single strata, it will cause differential settlement. Next cause is drying of soil surface layers. This is another cause of differential settlement if soil surface layer dries. Then proximity of trees with large roots. That is, if there is trees having large root, it will cause settlement of this part of the structure. So that is another cause. Then pipe leakage, sewer drainage, etc. And plumbing leakage. If there is any leakage, the soil here the soil will loosens, and the settlement of the soil occurs at this section. Okay, so that is another cause. Then excavation near the structure. Then different dimensions and depth of structure foundation. That is, if the dimensions of foundation varies, it will cause differential settlement. And the time difference between construction of other parts of the building. If the construction of other parts of the building is varying at different times, it may cause irregular load distribution, so it will cause differential settlement. And difference in load structure and large load area. So these are the some causes of differential settlement. Okay, so in this figure, causes of differential settlement are shown. Tree roots, then poor compaction of the soil on which we are constructing the building, then plumbing leakage, then poor drainage. If water is not drained out, it may cause loosening of the soil and will cause differential settlement. Then expansive, if there is an expansive soil like black cotton soil, it will cause differential settlement. So these are some of the causes of differential settlement. Next is methods to reduce differential settlement. So I have told that by providing raft foundation with a thick slab, we can reduce differential settlement. That is, raft foundation means we are providing a thick slab for the entire structure, so that the building will not settle non-uniformly. The settlement will be uniform. If there is any settlement, it will be uniform if we are providing entire slab for the structure. Next is use deeper underground space to reduce pressure on the soil. That is, by providing deeper underground space to reduce the pressure, we can eliminate differential settlement. Then transfer load to the stronger and not easily compressible soil with the foundation applied, such as piles, caissons, etc. That is, if the soil is not strong, that is, if the shear strength of the soil is very low, we can provide deep foundation like piles, caissons, etc. so that differential settlement is eliminated. Okay, that is usually in clay soil we are providing pile foundation. That is expansive. Also in expansive soil we are providing pile foundation in order to reduce the differential settlement. Next is methods of repair of soil. That is, we can improve the soil strength by soil repairing methods. So by improving the shear strength, soil strength, we can reduce differential settlement. So these are some of the methods to reduce differential settlement. Okay, so we have discussed different types of settlement, different stages of settlement like immediate settlement or elastic settlement, then primary consolidation settlement and secondary settlement. And also differential, one kind of settlement is known as differential settlement. That is, the settlement is not uniform here, so it is very dangerous for the structure. So we have discussed the causes and methods to reduce differential settlement. So next class I will in the next video I will discuss ground improvement techniques. Okay, thank you.